All right, let's verify this identity. So when we're verifying identities, we want to take a look at both sides and kind of say to ourselves, which one of these two sides looks a little bit more difficult. In this case, I'm going to choose the left-hand side because we have an addition going on inside of this sine function and a subtraction going on inside of the sine function. So I'm going to pull out the sum and difference formulas for sine. They're listed out over here on the right-hand side, but I'm just going to basically fill in and then work some algebra after that. So sine of alpha plus beta, I'm going to replace it with the right-hand side here. So I can say that's sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. And maybe I should put parentheses around everything so it's very clear. All right, so all that just got filled in for sine of alpha plus beta. To that, we're supposed to add sine of alpha minus beta. So I'm going to, again, cut and paste everything that's on the right-hand side, right where the sine of alpha plus beta was, because these are equal. So sine of alpha times cosine of beta minus cosine of alpha times sine of beta. All right, so we filled in using our sum and difference formulas for sine so far. Next, let's do a little bit of algebra and see what can we simplify down from here. So it looks pretty similar, all of these do, but we should notice as we kind of go through here, we have sine alpha, cosine beta, minus cosine alpha, sine beta. All right, so those don't match up, but what does match up, it looks like these have the exact same thing, right? Cosine of alpha, sine of beta, minus the cosine of alpha, sine of beta. So one's positive, one's negative. Those are going to get to simplify down and make 0 cosine alpha, sine betas. But then these two are the exact same, right? We have sine of alpha, cosine beta, plus another sine of alpha, cosine of beta. So we can combine those together. We have two of the exact same thing. So we have two sine of alphas, cosine of betas, and that's what the right-hand side looks like. So with that, we've proven it. We've shown that this identity does hold based on the addition, the sum and difference formulas for sine. All right, I hope this helps out. Good luck.